Hello, hello everyone. So I'm Sharma. I'm a co-founder and director of artificial intelligence at agents.ai, Chennai. So what is AI? Artificial intelligence. So the term artificial intelligence is first coined in the year 1956. The main objective of this artificial intelligence is to replace the human. But we human are a generic intelligence system, which means we do everything. We do driving, cooking, talking, running, and we do multiple tasks, right? So replacing a human it's not a easy task to do. So we thought to replace humans task. Instead of replacing humans, we can replace human task. To replace a human task, we need to have the same intelligence system that human has to do that task. But how do we humans learn? So we learn each and everything from the past experience. So the same way we are going to use to make the machine to learn. So we are going to use the historical data which is stored in the database to learn to make the machine to learn something out of it. The major difference between human intelligence and artificial intelligence is the speed and the memory. We humans, we always forget certain things, whereas the machine doesn't. And the speed the machine process and information is quite better than humans. So what we are going to do is we are going to make a machine to learn something out of the data. And how do we make it? So there are two ways to make a machine to learn something out of the data, and one is machine learning and other one is deep learning. The difference between machine learning and deep learning is the difference between 5 years old and 10 years old child. So we can say the difference between 5 years and 10 years old child is the maturity. In other words, we can say that as a capability of their brain. The same way, machine learning, it calculates or it predicts the future, or it predicts the output for the future input based on the mathematical relation between input and the output in the historical data. Whereas deep learning, it applies a feature engineering, it learns from the features. Instead of learning from the mathematical relation, it learns from the features. So machine learning is nothing but just applying a statistical as well as linear algebraic equations over the data and extracting information that we need from that. Let us say x equal to 2, y equal to 5, x equal to 3, y equal to 7. And what is the output for the x equal to 7? So output is 15, because from the historical data 2 and 3, I found the equation 2x plus 1 is the output, right? So y equal to 2x plus 1, where x equal to 2, 2 plus 2, 4 plus 1, 5, and 3 into 2, 6 plus 1, 7, like this. So we just derived a mathematical equation from the given data, and this is what a machine learning is. A deep learning is observing or learning from the feature or from the segment of the images or from the segment of the data to learn better than machine learning, and which uses a neural network, which is the major process or which is the major stuff in the human's brain. So machine learning is further divided into three major categories. One is supervised learning, other one is unsupervised learning, and third one is reinforcement learning. Supervised learning is that we do some supervision in the training stuff. Let's say I have an images, 300 images, and in each out of the 300 images, 100 images are apple, 100 images are orange, 100 images are papaya. Now I'm going to keep these 300 images in 3 different folders based on the object, and I'm going to label that 3 different folder with the name of that object. Let's say I'm going to enable the folder Apple, and I'm going to keep all those 100 images in that, and like that I'm going to do for rest of the object. Now this algorithm has to do only one thing. The why these people are calling this as apple and this as orange, right? So the major portion or the main role of the algorithm is to find out the reason why we call this as object. Let's say the size, the texture, or the shape of it. And let us say if the test object comes and it has to apply the features it learned from the 3 different objects to find out what object is the test object is. So this is what we call this as a classification. We call this as a classification, and this is the one subcategory in the supervised learning. There is other subcategory in the supervised learning is a regression. Let's say whenever there is a continuous output for the continuous changes in the input, if there is a continuous changes in the output, let's say we do have a different sales value every day, we do have a different temperature every day, we do have a different stock price every day. So every day is the input which is continuously changing, and based on that every day we are getting a new output which is continuously changing. So whenever we have the situation where the output is continuously changing as well as input, right, and we call that as a regression, right? So so we, in a very simple, if you have input and output to learn something from the data, if you have input and output in the data set to learn, and that is called supervised learning. In that first case we have a label, the folder name is a label, we have 100 images and corresponding labels. And the next case, whether if it is a sales, we have a day 1 the sale value, day 2 a sale value, right? The other stuff is unsupervised learning. Unsupervised learning is nothing but the same example. I'm going to keep all these 300 images in the single folder, and now the job of the algorithm is to find out how many objects are there in these 300 images, and it has to segregate that 300 images into 3 different objects or 3 different groups. So that is what we call that as a clustering, right? So let's say we are going to find out the targeting customer or targeting customer group from the group of customers, right? So here we don't have outputs, all we have is only input. From the input we need to identify the output, right, based on certain features, right? And the other subcategory is a dimensionality reduction, where we do dimensional reduction is nothing but cropping, right, compression, right? So cropping is a lossy compression, so dimensionality is also in that way. So we reduce the dimension of the data and to do some other operations. Third category, reinforcement learning. So reinforcement learning is completely based on 2 different stuff, reward and penalty. Let us say an example of a chess game. In a chess game, for each and every step that we take, we have 2 options to land. One, we either lose our coin or we take the opponent coin. So we have 2 options, either we lose our coin or we take the opponent's coin. If we lose a coin, we call that as a penalty. If we take the opponent's coin, then we call that as a reward, right? And as number of games passes, we collect this reward steps. We just collect or we have the accumulation of procedure which leads us to our reward. So with this collection we do a better gaming, we play better than the first or previous, and this procedure is called policy. And reinforcement learning is completely based on generating this policy and executing based on this policy. Example, robot navigation, auto car parking, and all these things are based on reinforcement learning. And this is a general example implementation steps that we follow in the machine learning application. So whether we have supervised learning or unsupervised learning data, we send that data into a extraction, feature extraction, where it extracts the features from the input data set and it sends that data to a model. So here model is nothing but some algebraic or statistical equations. It may be a probability or conditional probability, or it may be some linear equations. And from the data, so we apply these informations, or we apply these mathematical relation, or we apply these mathematical formula on the input data, and we derive certain information from that, and we call that as a model or predictive model, right? So let's say in this case we have some group of image objects. Let us say take here the features are the number of edges. For the square we have 4 edges, for a circle we don't have any edges, 0 edges, and like that we have number of edges, and this is the stuff. So here model learns if it is a square, then it should have 4 edges. And when we send the new test data, to the learned or trained model, it applies this feature, or in simple it applies, or it tries to extract the number of edges in the test data, and based on that it predicts the object. The typical ML cycle is follows, like we have a whole data set, we divide the data set into training and test portion, because we need to find out the reliability as well as the accuracy of the model. So we need to have a data set with input and output. We need to have the data. We need to have a data set with input and output. So we will give this 80% of, let's say if we divide the data set into 80%, 80:20, 80% of data is for training, 20% for testing, and we give this 80% for training. The model or the algorithm will get trained from this 80% of the data, and to test this model we use this 20% of data. That too will give the input of this 20% of the data to the model, and that model doesn't know the output for this 20% of input, so it predicts something, and we actually have the actual output with us, and we compare these two data, that is predicted output and calculate the actual output, and we calculate that as a accuracy. So more the accuracy, more the well trained the model is. If we don't have, if we are not getting better accuracy, then we will go for retraining or some parameter tuning. So based on this we will decide the performance of the model. So some of the famous or widely used algorithm in the regression is linear regression, and again it has some other variants like ridge regression, lasso regression, all these things. And in supervised there is other category, classification problem. For that we have logistic regression and SVM. For unsupervised clustering problem we have k-means, and for dimensionality reduction we have PCA. Deep learning. So as I said, deep learning is like completely based on the neural network. Neural network is a replica of human's brain. So the human brain process information based with the help of neurons, and neurons has 3 parts. One is input part, output part, and the processing part. So input is nothing but dendrites, output is nothing but axon, and the processing part is nothing but nucleus, where the information gets processed. So like that we have same structure: input layer, hidden layer, and output layer. In input layer all the informations from the others data or from the data set will be gathered, and that information will be sent to the hidden layer, where all the informations will get trained, and the processed information will send to the output layer. So from the results of the output layer we are getting the answer. So this is a typical one single neuron network. We call this as a perceptron. So where x1, x2, x3 are the input, and w1, w2, all these things are called weights. So for each input we randomly assign some weight, and based on that weight we calculate the output for the given input, and along with that weight we have a randomly selected bias which decides the output. And activation function or activation gate is like it acts like a gate. It just opens for the output. If it is a binary out classification, we have ones and zero. So activation gate remains closed, which means the output is 0, and if the activation gate is open, then output is 1. So this is a structure of multi-layer perceptron, which means we have multiple single neuron network or multiple perceptron architecture. So this is the vanilla neural network where we have one input layer and 3 hidden layer with one output layer. So there is no restriction in selection of number of hidden layer, but we have two different problems when we have more hidden layer, that is vanishing and exploiting gradient descent problems. To overcome that, we are going for a feed forward network, which is nothing but RNN, and this is the architecture of CNN. So tools, all these tools are completely open source tools that we will use all these tools in our course. So the machine learning is mainly highly depends on scikit-learn, and data wrangling and data pre-processing are completely depends. So we will use pandas. Matplotlib is the library that we will use for data visualization. Apart from these libraries, we have other stuff like OpenCV, TextBlob, and SciPy, dlib, all these things. So everything will be used for a particular test use cases. And apart from that, we have some deep learning like tools also, Caffe2, CNTK, TensorFlow, Theano. Everything is completely open source, and we will use each and every tool in our course. So there are so many applications for this artificial intelligence, and especially in marketing and finance, and there are some other upcoming or future applications, including natural language processing, cognitive stuff, or autonomous car, and all these things. But my personal suggestion is the NLP, the natural language processing, will rule the world in the next 5 years. So there are so many coding languages are there for implementing or developing AI application. But Python is widely used since it has n number of libraries for each and every line we can use, or each and every process, every step has its own library, right? And apart from Python, we can use Julia and R, where R is highly recommended for a data wrangling and data visualization, and Julia is one of the new language that is released in 2012. They are mainly focusing on machine learning. Things you will learn in this course is, so we'll learn Python from the basics, and we'll teach Python up to intermediate level, along with Python. Then I will learn about linear algebra, calculus, and statistics. So everything will be in applied stuff, and we'll learn machine learning, then we'll learn deep learning. So in Python we have n number of hands-on, like every topic we do some minimum 2 or 3 hands-on, and we will have hands-on in mathematics, applied mathematics, and we take specific use cases, and we take specific data set for each and every algorithm that we study in the machine learning. And we study almost around 20 different algorithms in the machine learning, which means we are using too many different tools to implement that algorithm, and we take different case studies, we take different use cases to learn or to make machine to learn for that algorithm. And we deep learning, we take two different paths. One is image processing as well as text processing. In image processing, we will use some digits identification and object identification, and like that we have use cases for the text processing. And in deep learning, we will learn about almost 8 different algorithm, and we'll use keras and tensorflow. You can ask me any questions. Thank you. And thank you.